differentiability. And this is the function that we're going to explore. It's x squared times sine 1 over x when x is not equal to 0, and it's 0 when x is equal to 0. And the question is, show that the derivative of x exists for all x. The derivative of the function exists for all x. So we use the definition of the derivative.
Why are you investigating in x is equal to 0?
I haven't come that far.
Okay, sorry.
So, what we want to do now is that we want to find the derivative when x is equal to 0.
Why?
I don't know.
Is there a problem in any other point?
No.
Well,
Isn't it minus f of n?
When x is equal to... Oh yes, of course. It is. Well, all other points are fine. The only point that there's a question mark, where there's a question mark, is when x is equal to 0. Because that's where the function changes.
Don't you mean when it's slightly before and after 0? Because we know that
Yeah.
it's when it's 0.
But it's the limit at 0, so by definition it's before or after 0.
Mm. We want to know what happens to the function as it approaches 0 from both sides. From above and from below. So we start by plugging in 0.
And do we have to investigate from the left and the right, or just in general?
This is in general.
Okay.
This is in general, yes. And f of 0 is equal to 0. So this will be f of h divided by h. And since
What are we looking for again?
we're looking for
Derivative.
the derivative, we want to see if it's differentiable
In
0
x is equal
when
to
x is
0.
equal to
Okay.
0.
Hmm?
We know that f of 0 is equal to 0, but we don't know what f of h is. So we need to use the other part of the function.
Because h is never 0. So we can use the upper function.
Yeah, because h goes to 0, but it never becomes 0. So we plug in h. And we can cancel out an h to get this. And sine 1 over h is always between 1 and minus 1. And as h goes to 0, this h will become 0. So the whole limit will become 0.
Did everybody get that?
Any questions?
I didn't. Can you tell me again?
Well, we wanted to find the derivative when x is equal to 0. We want to find the limit of the derivative as x approaches 0.
No, this limit is the derivative. You're not finding the limit of the derivative.
Aren't we?
No, this limit is the derivative.
Are you sure?
Absolutely sure.
Precisely.
So we're not looking for the limit of the derivative. This is, if this limit exists in x is equal to 0, the derivative exists.
All points. For all x.
For all, I mean, there's no problems with the other x values. So
So
then,
for
then
all x.
for all x. Yeah. Continue.
The edge says, why can we cancel out f of 0? Or, oh yes, sorry, not because it's 0, sorry. That was my question.
What?
Never
Why?
mind, never
Good
mind,
question,
never
Felix.
mind. question.
Yeah, but I didn't understand the question. Why can't we?
He was wondering
no,
why-
sorry,
he
I
was
forgot-
wondering-
I forgot
he was
no,
wondering-
no, the difference here.
I think it was a good question. He was wondering
sorry.
why we could cancel out this f of 0.
That's a very, very good
That's a very
question.
good question. And that's because f of 0 is equal to 0.
I know that, but I forgot when I had to.
No, but that's we had a hang up on
Very
that.
valid question.
Yes.
You were wondering that too.
Yeah, I know. I was.
Should we move on to B?
Now, what have you proved?
Or, we proved that the derivative exists when x is equal to 0.
And we
and
also
that
got a
it's-
value for
and
the.
that it's equal to 0.
I don't like this part.
So
Support.
When you plug
Uh-huh.
in, this is y f prime of 0, right?
Mm.
you can make an arrow.
Good. But I think there is more to enjoy here, isn't it? Isn't it beautiful that we actually have proved that the limit exists and therefore we find the derivative, right?
So f prime of 0 is 0.
Mm. And that's question B, isn't it?
That's question. What is question B?
Question B is find the derivative when x is equal to 0. And that's what we just did.
Yeah.
It's equal to 0. So it's meant to make you reflect on what you just did.
So
We just did it.
you say that h times sine h inverted is equal to 0 because h is going towards 0, or because sine 1 divided by, or sine h inverted is going towards 0?
Sine 1 over h is always between 1 and minus 1.
Okay.
And h goes to 0.
Okay, so it's because h goes.
Yeah.
What is the theorem you're using here in order to prove that limit?
This theorem,
Yeah, Vicky.
Squeeze theorem.
Squeeze theorem, right?
squeeze theorem. Any more questions? So C is find the derivative when x is not 0. And to do that we use the product rule. And the board. Should I take this away? Or?